So here is the deal. Okay, so here's the deal for today. I want to answer any questions you got on the homework. First hour it was none, fifth hour it was 1, the sixth hour it was like 4. So whatever questions you got, I will answer. We have time. When I'm done answering your questions, I'm going to do a quick demo that will help you with video 1.4. And then when we're done with the demo, you guys are going to do a real quick target check to make sure you guys are doing okay with acceleration. And that's it. Okay? If you finish all that early and you want to get started on the video, you can. If you're already done with the video and you want to get started on the worksheet, you can. There you go. That's what I know. Griffin and then Simon.
I'm confused between like 7 and 13 as long as that goes.
7 and 13. Got it. Okay, Simon? 9? 15? These are same ones I did last hour. Allie, what do you got? 11B. 11B. These are, I think I just deleted them, but I think that's the exact same ones I did last hour. That's funny. All right, what else? Going once, twos, threes, sold. Okay, cool. So let's do it. Oh no, I also did number 4 last time. Let's see. I am going to, if nobody objects, do number 9 first. And then I'll come back and get 7 and 13, which are both similar. Okay? So any of these problems that involve rolling a ball up a hill, my recommendation is start by making a simple drawing. Okay? So in number 9, for example, it says a ball rolls up a hill at 3.6 meters a second and it slows down at 1.3 meters a second squared. What's the velocity of the ball after 4.3 seconds? So you've got this hill with a ball. So the ball is going to go up the hill and come back down it. And you're given sort of a starting velocity, right? You're told that at the beginning it's going at 3.6 meters a second. So identify that and label. Okay, well my velocity at this point is 3.6 meters a second, right? Automatically I know the velocity at 2 other points. So go ahead and put those into your drawing. I know when the ball's up here at the top that the velocity is 0. And I know when the ball gets back down to the bottom, the velocity is negative 3.6 meters a second, right? The problem also tells us that the ball slows down at 1.3 meters a second squared. So 1.3 meters per second squared, just because it's meters per second squared, automatically I know that's a measure of acceleration. All right? Now, before I go any further, so that's sort of all the given information, with the exception of the time, which I'll get to in a second. Before I go any further, let's take a second and check all these signs. So this velocity here, positive or negative? Positive, right? Because it's going uphill. So this is positive. I'm going to put a little plus to emphasize that I checked it. All right? And then I already marked this one. This one I made negative because it's coming down the hill. And then 0 is 0, right? So is everybody good with the sign on velocity? All right, now let's talk about acceleration. What does it mean for acceleration to be negative, you guys? Velocity is decreasing is the only correct answer. I heard a couple people say going downhill. No. And I heard a couple people saying slowing down. No. The only correct answer, negative acceleration means decreasing velocity. Only right answer. Okay, so in order to figure out if this is positive or negative, I need to think about what my velocity is doing. So let's look. On the way up, the velocity goes from 3.6 to 0. Is that an increase or a decrease? Decrease. Okay, so I'm hoping that it makes me feel like the acceleration is going to be negative. Let's double check. On the way down, the velocity goes from 0 to negative 3.6. Increase or decrease? Decrease. Still a decrease. Aha! My acceleration has got to be negative because v is decreasing. Does that make sense? So my guess is whoever asked about number 9 probably just forgot that negative sign. Okay? So what I'm trying to encourage people to do is to make a drawing, write out what you know, and then check your signs. Okay? So everybody good up to there? All right, so now let's look at what the question wants to know. The question says, in number 9, what's the velocity of the ball after 4.3 seconds? Meaning 4.3 seconds after it started. So I don't really know where the ball is after 4.3 seconds. It might be still on the way up. Maybe it's at the top. Maybe it's on the way down. I don't know. But what I do know is that the 4.3 seconds begins here, right? So my initial velocity for this problem is 3.6 meters a second. My acceleration is negative 1.3 meters a second squared. The time is, what did I say, 4.3? 4.3 seconds. And what are we looking for, you guys? Final velocity. I want the velocity at the end of that amount of time. Make sense? All right, so let's solve this thing. So I gave you guys the equation the other day. It's this, Vf equals Vi plus A times t. And I'm going to plug in the numbers. So 3.6 was my starting velocity. Acceleration is negative 1.3 meters a second squared. Time is 4.3 seconds. Multiply, add, solve, math. You get negative 1.99 meters a second. So there's the answer. What's the significance of the fact that I got a negative? It's telling me it's coming back down, right? So if you had to approximate, about how far down do you think it is? Ish. A little past half, probably, right? I don't know, somewhere in here-ish, right? So there you go. There you go. So at the end of 4.3 seconds, it's coming down at 1.9. Cool? Cool. Any problems with that? So if you get stuck, this is what I want to see you doing. Make a drawing, write out what you know. Okay? Now, when I say make a drawing, what I mean is draw the path that the object follows. Okay? Just drawing the ball isn't going to help you any, you know? Draw the path that it follows. And then you can use the path to identify important information at different points. Okay, so that was number 9. 7 and 13 are both very similar, so I'm going to plow through those pretty quickly, if that's okay. And if I go too fast and you need me to say more, let me know. All right. So for 7, you roll a ball up a hill at 20 meters a second. So the ball is going to go up, it's going to come down. You know that the velocity when you first roll it is 20. Velocity at the top is 0. Velocity at the bottom is going to be negative 20 meters a second. It causes the ball to slow down and eventually comes back down the hill. The hill gives the ball an acceleration of 2.5 meters a second squared. Question A wants to know the time it takes to get to the top, right? And question B wants to know the total time. Cool? All right, so should anything be negative that I haven't already made negative? Velocity is positive on the way up, negative on the way down. Acceleration ought to be negative. Okay? So for part A, to find the time at the top, what am I going to use as my VI for part A? 20, right? What am I going to use for VF? 0. And then do VF minus VI over A, and you get 8 seconds. Good? Is it this hour that I'm always falling on stuff?
Yeah.
I threw the desk across the room earlier, or the chair across the room the other day. Tripped on it, like, get out of my way. All right. Okay, everybody good? So then to find the total time, you can either just double it, right? Or go back and use this as VI and this as VF and solve it again. Cool? I don't remember who asked about this one now. Does that make sense? So where did you get tangled up, Chris?
I just didn't know that since it started at 20, that it also ended in negative.
Gotcha, the path was symmetric.
Yeah.
Is it symmetric or symmetrical?
Symmetrical.
I feel like that's a thing that I should know, having done a lot of math in my life. Okay, there we go. So that's number 7. 13 is kind of the same issue. Cool? All right, does anybody need me to do 13? All right, so let's see where are we at. So we've done 7 and 13. We've done 9. 15 I'm going to do last. 11B. All right, so I like 11B. This is another really good example of understanding time intervals. All right, so here we go. Number 11. says a supersonic jet flying at 145 meters a second is accelerated uniformly. That's a fancy way of just saying that the acceleration is constant, which it always will be in this class, at a rate of 31 meters a second squared for 20 seconds. So let's draw this. So here's our jet. All right. It's a very happy little jet. All right. So it's flying at a velocity of 145 meters a second. And then 20 seconds go by. So eventually the jet ends up over here. Oh, got a little fat on the way. Whoa, why are you throwing stuff at
I
me?
meant for that to land gently, and there's a note inside, and I didn't want you to see it because I wanted you to read it later.
Okay, I got you. Okay. That's okay. All right. All right. So while it's moving, it's accelerating at 31 meters a second squared. Okay. So everybody good? Yes. Okay. I will maybe later. All right. Now, should anything here be negative?
No.
Nope. It's moving forward. Velocity's increasing. Cool. What are we trying to find in part A?
The velocity reaches.
The velocity it gets to at the end of this time, right? Okay? So for part A, I know my initial velocity is 145 meters a second.
This is the last call for light touch pictures at this time. Anytime has not yet taken your picture, this is the last call for light touch. They are in the auditorium, and they should be sending us a picture in the next 15 minutes. Thank you.
Okay, so we're trying to find our final velocity. It's literally just plug and chug from that point. Everybody cool with A?
Yeah.
Problems? Okay, now part B, I'm guessing, is where people got stuck. Yes? I don't remember who asked about this one, but yeah. Is that where you got stuck on B? Okay, so B says the speed of sound is 331 meters a second. When does the jet hit the speed of sound? So the idea is, look, my jet started out at a velocity of 145. And by the time it got to over here, the velocity was 765. So do you guys agree that if I'm going to go from 145 to 765, somewhere in the middle there has to be a point where my velocity is 331 meters a second, right? Follow? And I want to know how long it takes to get there. From where? So we're talking about a time interval. Where does the time interval start? Where does the time interval end? So where does it start, you guys? 145, and then it goes to there, right? So that's the time I'm looking for. Follow? So, okay, so for this red time interval here, here's the stuff I know. I know my initial velocity is 145, right? Because that's how fast it was going when the jet first started moving. It's still gaining velocity at the same rate. I'm trying to find out how much time it takes to do what? To get to 331. So what is that 331 a measure of? Final velocity. So let me pause for a minute. Sometimes this weirds people out. I got two different final velocities. In part A, my final velocity was 765. Now my final velocity is only 331. How can I have two different final velocities? Does that make sense? Is it a contradiction? What do you got, Caleb? Oh, right? No, Hamza. Damn it. I'm so sorry. Sorry.
765, that measurement was 20 seconds. And this is for
Perfect. That's exactly right. They're different time intervals, right? Sorry about that. They're different time intervals, right? Allie, does that make sense?
Yeah.
So now, I know my information. I'm just going to find my time. And plug in the numbers. 331 minus 145 divided by 31, and it gives you 6 seconds. Cool. Is everybody cool? Anybody unhappy about number 11? Or anything other than number 15? Alrighty then. So number 15. So somebody from one of my other classes came in this morning or no, yesterday after school and said, hey, you know those problems with all the positives and negatives where you got to circle the positives and the negatives and the zeros? And I said, yeah. He said, I think those suck. He didn't notice it. He said, I don't know how to do those. So he helped me, and I said, yes. And so we worked on it for a little while, and then at the end I said, here's a thing. He said, that's helpful. You should show that to everybody. So I'm going to show that to everybody, right?
Yeah.
So here's the deal. All of those problems where it says circle the positives and the negatives and the zeros and stuff, they're all about an object moving in some direction and then either speeding up or slowing down. And you need to tell me if the velocity is positive or negative or zero, and if the acceleration is positive or negative or zero, right? So the zeros are easy to identify, right? What does it mean if a velocity is zero? Then you're not moving. That's acceleration. Velocity of zero means you're not moving. Okay, so a lot of the time it'll say like, a ball rolls down a hill from rest. From rest means not moving, right? Okay, so that's a velocity of zero. And then an acceleration of zero means moving at a constant speed or constant velocity, right? Technically, yeah. Good? So the weird ones are where you're speeding up or slowing down or whatever, right? So there's only 4 possibilities. Here are the 4 possibilities. Somewhere, here we go. Okay, so this looks super overwhelming. I don't think it's quite as bad once you figure out what it is. All right, so here are the 4 possibilities. If your object is moving forward, then it can be either, as it moves forward, it can either be speeding up or slowing down, right? Or the object can be moving backwards. And as it moves backwards, it can be either speeding up or slowing down. Cool? What if the problem is about something moving up or down? Well, up is basically the same as forward, right? So that's positive. And down is basically the same as backwards. Cool? So this is it. These are all the possibilities. So how did I come up with these values? So for each one, I wrote down whether my velocity was positive or negative and my acceleration was positive or negative. So how do I know if the velocity is positive or negative, you guys? Direction of motion, right? So both of the problems where the car is moving forward have a positive velocity. So, you ready for this? I'm excited. I'm going to do a thing. Forward corresponds to positive velocity. Forward corresponds to positive velocity. And similarly, backwards corresponds to negative velocity. Backwards corresponds to negative velocity. Follow? All right, so now we just got to figure out the acceleration. So when is acceleration negative? Not slowing down. Decreasing velocity is the only correct answer. Okay? Sorry, somebody over there said that and I jumped on you, but yeah. Negative acceleration means decreasing velocity. So now what we need to do is go through each of these examples and decide if our velocity is increasing or decreasing. And then we're done. All right? So if you're moving forward and speeding up, I made up some numbers. So suppose my car is moving forward and speeding up. So maybe it's moving forward at 10 miles an hour, and then it speeds up to 20 miles an hour. Since it's moving forward, those velocities are positive, right? So my velocity is going from positive 10 to positive 20. Is that an increase or a decrease? It's an increase, right? So here, I've got increasing velocity, and therefore positive acceleration. Ooh, look what it did. Wow. When we get to light, I didn't know it did that. Sorry. All right. All right. So there's another one like this. Over here, look. In this one, we're going backwards and slowing down, right? So since we're going backwards, the velocities are negative, and we're slowing down. So I said, all right, well, let's suppose we're moving at 20 miles an hour, and then we slow down to 10. So the velocity in this example is going from negative 20 to negative 10. So if your bank account went from negative 20 to negative 10, that's good, right? I mean, it's not great, but it's better, right? Because it's less bad, right? So that's an increasing velocity, and therefore a positive acceleration. Follow? All right, so then the only other ones are these guys. So in this one, we're moving forward and slowing down, right? 20 miles an hour down to 10 miles an hour. They're both positive because we're moving forward, right? So here, Your velocity is going from positive 10 or positive 20 to positive 10. That's decreasing velocity, which corresponds to negative acceleration. Over here, same idea. If you're going backwards and speeding up. So we're speeding up. So we're going from 10 miles an hour to 20 miles an hour. But they're both negative because we're going backwards. So if your bank account goes from negative 10 to negative 20, that's bad, right? So that's a decreasing velocity, which corresponds to negative acceleration. Does that make sense? That's it. Those are the 4 cases. Cool? Is that helpful?
Yes.
There you go. That's a thing. Questions on it? Write it down, take a picture of it, or, yeah, those are your choices. Okay, so with that in mind, let's run through number 15, and then unless you guys have questions, I am done with you. I will get out of the way so I'm not in your picture. You guys ever had coffee before? Good. Don't start drinking it. You're too young. It'll stunt your growth. All right, here we go. Number 15. Timmy throws a ball up in the air at 14 meters a second. So when you throw a ball up in the air, is it going to speed up or slow down?
And then slow down.
Well, it speeds up while you're throwing it. Maybe that's what's messing people up. So all these problems are about throwing a ball up in the air or rolling a ball up a ramp. All begin when you let go of it. Okay, like Roy rolls a ball up a ramp. The problem begins when he rolls it. And then what happens after that? Same thing when you throw something up into the air. The problem begins when you let go of it. Okay? So, based on that, after you let go of it, is it going to speed up or slow down? Slow down. So here we've got an example of an object moving up. I don't see up on my list. What should I use? Okay, so it's moving forward, up, and slowing down. Aha! Positive velocity, negative acceleration, right? It's moving in a positive direction and slowing down. Yeah.
So why did some of them start at 0?
So that was what I said. This chart doesn't include the zeros. And I'll get to one like that in a second. Okay? So is everybody okay with A? Do you understand why A doesn't start at 0? Because when you first throw it, it's moving, right? All right. B, a car drives straight south at a constant speed of 60 miles an hour. Not up there. Why? No acceleration. That's a 0. Right? It's not speeding up or slowing down. So velocity is negative. Acceleration is 0. Cool? Savannah, does that make sense?
Yeah.
Everybody? Cool. B, a ball rolls from rest down a hill. So initial velocity is 0, but as soon as it starts rolling, it's going to become negative because it's going down, right? Okay? And from there, it's going to speed up or slow down? Speed up. So we got a thing that's moving in a negative direction, backwards, and speeding up. So it's this one, right? Okay? So initial velocity is 0, but then your acceleration is going to be negative. Make sense? D, backing out of your driveway when you hit your brakes. Which one? Backwards and slowing down, right? Initial velocity is negative, acceleration is positive. Okay. Flower pot falls from rest out of a window. So while it's falling, the initial velocity is going to be 0 because it's going from rest. And then the velocity gets more negative, so negative acceleration. Cool. Questions? Super quick explanation, or super quick demo. I'm going to keep this short because I talked longer than I had hoped to. All right, so the video tonight is about free fall, dropping stuff. Okay, you'll get a better definition in the video. All right, but so when you drop something, it falls. As it falls, it speeds up, right? So suppose I went to the roof of the building and took a whole bunch of garbage with me and I dropped it all off the roof. And I dropped like a bowling ball and a feather and a giant car and a raccoon and an elephant and all these different things, right? I wouldn't do that because I would hurt the elephant. I was trying to think of something big. Elephants are big, right? So I'm going to drop all these things off the roof, all right? But before I do, I say to you, which one's going to hit the ground first? Most of you are going to say the one that is the biggest or the heaviest, right? Because heavy stuff falls fast. We all know that, right? Sort of. All right, so let's suppose we all agree on that. We're like, yes, heavy stuff falls fast, always. Heavy stuff falls fast. Well, let's test that theory, okay? So to test that theory, what I'm going to do is I'm going to take a heavy thing and a light thing and drop them, and we'll see which one falls faster. Okay, so I have a book and a piece of paper. I'm going to drop them. If you have sensitive ears, cover them. Which one of these two things will hit the ground first? The book, because it's heavier. Here we go. Ready, set, go. Go paper. The paper never wins. Okay, so the book fell faster because it's heavier, right? Okay, so awesome, we proved it. Heavy stuff falls faster, right? I feel like we should do some more tests. All right, so let's mix it up a little bit. I'm going to use the same two objects, but let's change the circumstances under which they're being dropped. Let's give the paper a head start and do this. Okay, so is the heavy object going to somehow win? No, but so what do you think is going to happen? The paper is going to get there first by a lot, so the paper is going to like go, and the book is going to go. No, they're going to fall at the same rate. So is the book going to make the paper go faster, or is the paper going to make the book go faster? No, I said that wrong. Is the book going to make the paper go faster, or is the paper going to slow the book down? The book's going to make the paper go faster, right? Okay, so let's try it. So I got the paper under the book. We're going to drop it. Here we go. No big surprise. They fell at the same rate. Technically, the paper won because it was on the bottom, but they fell at the same rate. So the heavy thing didn't fall faster there, but you might argue, well, the paper there wasn't really falling because the book was pushing it down, right? Okay? So, I'm not exactly sure what's going on. All right, let's try flipping it then. So what if this time, that last time the paper won, this time let's give the book a head start. Drop it like this. What do you think? What's going to happen? Well, if our theory is true that heavy stuff falls faster, what should happen? The book should win, and then the paper should come down after it, right? Because heavy stuff falls faster, right? So let's try it. Ready, set, go. What? Okay, so I hear some of you guys saying suction, air resistance. So look, when I drop the paper, see how it floats? What causes that? Air resistance. The paper has to push the air out of the way. Technically, so does the book, but the book is so heavy that the air sort of can't put up enough of a fight to affect it significantly. We'll learn more about that when we get to forces. Okay? But for now, the idea is the air resistance doesn't affect the book as much as the paper because the book is so much heavier, denser, a few different ways to say it. Okay? And so the idea is the reason the paper falls slowly is not because it's lighter, it's because it's more affected by the air resistance. When I put the paper on top of the book and drop it, what happens? The book sort of pushes a path through the air. Now there's no air to slow the paper down, and so they fall at the same speed. Make sense? Okay? So, this idea that we have that heavy stuff falls faster isn't really true. Okay? Especially if you imagine things in a situation where there's no air resistance. Okay? So it turns out air resistance is crazy hard to calculate. Okay? And in any first-year physics course, we always assume there's no air resistance. Which I know is frustrating because there's air resistance in the real world. But in most ordinary circumstances, it doesn't have that big of an impact on the problem. Okay? So we will always assume there's no air resistance. And in those circumstances, everything falls at the same rate. Okay? The video you're going to watch tonight is about what that rate is. Cool? Questions? All right, I'll show you another example of that in a video tomorrow. It's like a 3-minute video. If you're not here tomorrow, I'll show it to you the next day. Questions? Okay, so real quick target check. We got about 12 minutes here. It should be more than enough time. When you're done, drop it in the basket, and then I'll see you either tomorrow or Monday or Tuesday. Oh, also, because people were struggling with that so much, I want to add one problem. It'll take you a minute. All right, so when I'm done passing these out, I'm going to put one more problem up on the board. Just put it on the back of your target check for me, okay? Wow, it's a lot longer than my other hours. Riffing. Okay, so that's that. And then when you're done with those problems, if you would please do this. Car's driving west and it speeds up. Is the initial velocity positive, 0, or negative? Is the acceleration positive, 0, or negative? Just do it on the back or even in the bottom right-hand corner would be fine. All right?